Okay, guys and gals, I want to show you this website right here. And this website is going to show us the different ways in which we can effectively change some factors or some variables and really determine and bring about a change, an increase or a decrease in the rate of a chemical reaction. For example, here's a variable that I have right here, and it says concentration. Well, concentration is essentially how crowded together, how much of the reactants do we have put together. And so obviously, you've probably all heard of like concentrated orange juice, concentrated lemonade. Woo! That stuff will really make your eyeballs spin because it's really tart. It's really acidic. So if we dilute it, we add it to or add water to it or into water, and we can dilute it and make it less concentrated. So concentrated is sort of like the strength of the solution. Well, if I decrease the concentration, you look over here. So here I have my A plus B. These are my reactants. And of course, it's going to yield something different. Now, in class, you and I said A plus B yields AB. This is just using C, so it's no big deal there. It's just a difference in using a letter. If I increase the concentration, wow, there's a ton more stuff in there. So let's decrease and let's run the reaction. So look, excuse me, look at, please look at this situation. I'll get it right sooner or later. And let's run the reaction. You can see that the amount of time goes by, but look at the amount of product. The amount of product that we're making levels off right here. Now, this would be a stable reaction that is at equilibrium, and by that I mean it is going along at a regular, common, constant rate. So let's go back and let's start over, and let's increase the concentration and see what happens. Well, obviously, we produce a lot more product. I mean, think about it. Over here, we were down here with our product. Up here, we're really high up in the air, or high up in the air, high up on the y-axis. So let's take a look at a different variable. Let's go surface area. So what happens if I decrease the surface area? In other words, I've got big chunks of material and I didn't break them up. Well, if I do that, then you can see that the amount of product that I get is going to directly relate to the surface area. If I increase the surface area, now I've got a lot more of these atoms that are no longer clumped, but they're kind of broken into pieces like we did with the Alka-Seltzer tablet when we produced the carbon dioxide gas inside the flask, a closed system. Well, if we go ahead and, increase this, now let's run the reaction. Well, you can kind of see what's going to happen. So what we're getting at is these variables of surface area, temperature. There's a good one. When you increase the temperature, in this case, we'll decrease the temperature, and we've got a lower temperature so we can see that the amount of product that's going to be produced is on the lower end here on the y-axis, right about here. Unfortunately, this is not, there's no graduations there. We don't see any numbers, but we can get an idea of where it is right here. So let's increase the temperature. So now we have a very high temperature, or at least somewhat higher. Look at the amount of product that we get. In every single situation, what did each factor do? It changed how and how often the collisions occurred. In order for chemical reactions to occur, collisions have to happen. So we can directly relate these variables right here. These variables, adding a catalyst, concentration. We didn't put adding pressure up here, but you know that one's there. Anytime you can increase the collisions, increase the energy of the particles while they are colliding, increase that activation energy, you can change the rate of a chemical reaction. Have a great day.